Question 1. Implementation of a new customer-facing feature using a third-party PL/SQL library has revealed a potential security vulnerability within that library. The development team is under pressure to deploy the feature by the end of the sprint. The vulnerability, if exploited, could allow unauthorized access to sensitive customer data. What is the most professional and ethically sound course of action? Option A. Proceed with the feature deployment as planned, assuming the vulnerability is unlikely to be exploited and addressing it in a future maintenance release. Option B. Attempt to fix the vulnerability within the application's PL/SQL code without notifying the vendor or seeking internal security review. Option C. Publicly disclose the vulnerability on developer forums to alert the wider community about the risk. Option D. Immediately report the vulnerability to the third-party library vendor and pause the deployment of the feature until a patched version of the library is available or a mitigation strategy is approved. Correct answer is D. Immediately report the vulnerability to the third-party library vendor and pause the deployment of the feature until a patched version of the library is available or a mitigation strategy is approved. Explanation. Scenario analysis. This scenario presents a common ethical dilemma in software development, where a developer discovers a potential security vulnerability in a third-party library that is critical to the application's functionality. The challenge lies in balancing the immediate need to deploy a feature with the long-term responsibility of ensuring the security and integrity of the system and its users' data. The pressure to meet deadlines can tempt developers to overlook or downplay such findings, but the potential consequences of a security breach, including data loss, reputational damage, and legal repercussions, necessitate a cautious and responsible approach. Correct approach analysis. The correct approach prioritizes security and responsible disclosure. Reporting the vulnerability to the library vendor allows them to address the issue systematically and release a patched version. This proactive measure protects the application and its users from potential exploitation. It aligns with best practices in software development and cybersecurity, which emphasize vulnerability management and responsible disclosure to mitigate risks before they can be exploited. This approach also demonstrates professional integrity and a commitment to delivering secure and reliable software. Incorrect approaches analysis. One incorrect approach involves ignoring the vulnerability to meet the deadline. This is ethically unsound and professionally irresponsible. It directly violates the principle of delivering secure software and exposes the organization and its users to significant risks. Such negligence can lead to severe security breaches, data compromise, and potential legal liabilities, undermining trust and reputation. Another incorrect approach is to attempt to fix the vulnerability independently without informing the vendor or following established disclosure protocols. While seemingly proactive, this can lead to incomplete or ineffective fixes, introduce new bugs, or even create further security holes if not done with expert knowledge. Furthermore, it bypasses the vendor's established process for managing and distributing security patches, potentially leading to inconsistencies and a lack of coordinated response across users of the library. A third incorrect approach is to disclose the vulnerability publicly without first notifying the vendor and allowing them a reasonable time to fix it. This is known as irresponsible disclosure and can be highly damaging. It immediately exposes users to exploitation before a fix is available, potentially causing widespread harm and making the developer or organization liable for the consequences. Responsible disclosure involves a coordinated effort to ensure security is addressed before public announcement. Professional reasoning. Professionals should adopt a decision-making framework that prioritizes security, integrity, and ethical conduct. When a potential vulnerability is discovered, the first step is to thoroughly investigate and document the findings. Next, follow established organizational policies for reporting security issues, which typically involve notifying the relevant security team or management. If a third-party component is involved, adhere to responsible disclosure practices by reporting the vulnerability to the vendor. This process ensures that the issue is addressed systematically and that the risks are managed effectively, protecting both the organization and its stakeholders. Question 2. Quality control measures reveal that a PL/SQL procedure intended to process customer orders contains a section of code that bypasses a standard validation routine by directly manipulating a temporary table. While this shortcut appears to improve performance for a specific edge case, it deviates from the established coding standards and introduces a potential risk of data inconsistency if not handled with extreme care in future modifications. The developer who wrote the code is aware of this deviation. What is the most professional course of action? Option A. Ignore the deviation, assuming it will not cause any significant issues in the future due to its specific edge case nature. Option B. Document the deviation and the reason for the shortcut in the code comments and proceed with the current implementation. Option C. Refactor the code to adhere to the established PL/SQL coding standards and best practices, ensuring robust validation and maintainability. Option D. Implement the shortcut without any documentation or notification, as it provides a perceived performance benefit. The correct answer is C. Refactor the code to adhere to the established PL/SQL coding standards and best practices, ensuring robust validation and maintainability. Explanation. Scenario analysis. This scenario presents a professional challenge because it involves a conflict between delivering a functional solution and adhering to established coding standards and best practices. The developer has identified a potential shortcut that, while seemingly efficient in the short term, introduces technical debt and deviates from the intended, more robust implementation. The pressure to meet deadlines can exacerbate this conflict, making it tempting to overlook such issues. Careful judgment is required to balance immediate project needs with long-term system maintainability and integrity. Correct approach analysis. The correct approach is to refactor the code to adhere to the established PL/SQL coding standards and best practices, even if it requires additional development time. This aligns with the Oracle database program with PL/SQL 1Z0-149. Exam's emphasis on writing efficient, maintainable, and robust PL/SQL code. Adhering to standards ensures that the code is understandable by other developers, easier to debug, and less prone to errors in the future. This proactive approach minimizes technical debt and promotes the overall health and longevity of the database application, which is a core tenet of professional software development. Incorrect approaches analysis. One incorrect approach involves documenting the deviation and proceeding with the non-compliant code. This is professionally unacceptable because it knowingly introduces technical debt and bypasses established quality control measures. While documentation is important, it does not absolve the developer of the responsibility to write quality code. This approach fails to uphold the principle of writing maintainable and robust code, potentially leading to future issues that are harder to resolve due to the non-standard implementation. Another incorrect approach is to ignore the deviation and assume it will not cause problems. This is a failure of professional responsibility and a direct violation of best practices in software development. Ignoring potential issues, especially those identified during quality control, can lead to significant bugs, performance degradation, and security vulnerabilities down the line. It demonstrates a lack of diligence and a disregard for the long-term implications of code quality. A further incorrect approach is to implement the shortcut without any documentation or notification, hoping it goes unnoticed. This is ethically unsound and professionally irresponsible. It actively undermines the quality control process and deceives stakeholders about the true state of the codebase. Such actions erode trust and can lead to severe consequences if the shortcut causes unforeseen problems. It directly contradicts the principles of transparency and accountability in software development. Professional reasoning. Professionals should approach such situations by prioritizing code quality and adherence to standards. The decision-making process should involve 1. Recognizing the deviation and its potential impact. 2. Evaluating the effort required to correct the deviation against the long-term risks of leaving it unaddressed. 3. Communicating the findings and proposed solution to project management or a technical lead. Explaining the rationale for refactoring and the potential consequences of not doing so. 4. Collaborating to find a solution that balances project timelines with the necessity of maintaining high code quality. This structured approach ensures that decisions are informed, ethical, and aligned with professional best practices. Question 3. The control framework reveals a PL/SQL developer has identified a potential optimization for a critical stored procedure that could significantly improve query performance. The developer believes they can implement this change directly without extensive testing, as they are confident in their understanding of the code and the potential benefits. However, the established development lifecycle mandates a formal change request, peer review, and rigorous testing in a staging environment before any production deployment. What is the most appropriate course of action for the developer? Option A. Implement the optimization in the production environment and then inform the team of the successful change, presenting the performance metrics afterward. Option B. Inform the team lead of the potential optimization and implement it after receiving informal verbal approval, bypassing the formal change control process. Option C. Submit a formal change request detailing the proposed optimization, its expected benefits, and a plan for testing and validation, adhering to the established development lifecycle. Option D. Implement the optimization directly into the production environment, as the potential performance gains are significant and the developer is confident in the change. The correct answer is C. Submit a formal change request detailing the proposed optimization, its expected benefits, and a plan for testing and validation, adhering to the established development lifecycle. Explanation. This scenario presents a professional challenge because it involves a conflict between a developer's desire to improve performance and the established, documented procedures designed to ensure data integrity and system stability. The developer has identified a potential optimization, but implementing it without proper validation and approval bypasses critical control mechanisms. The correct approach is to follow the established change management process, which includes thorough testing, peer review, and formal approval before deploying any code modifications. This represents best professional practice because it aligns with the principles of responsible software development and data management. Oracle's PL/SQL development guidelines and general IT governance frameworks emphasize the importance of a structured approach to prevent unintended consequences. This process ensures that changes are understood, their impact is assessed, and they do not introduce new bugs or performance regressions. Adhering to this process upholds the integrity of the database and the reliability of the applications that depend on it. An incorrect approach would be to immediately implement the optimization without following the documented process. This failure is a direct violation of established IT control frameworks and potentially internal development policies. It demonstrates a disregard for the established procedures designed to protect the system and its data. Such an action could lead to data corruption, application downtime, or security vulnerabilities, all of which have significant business and reputational consequences. Another incorrect approach is to implement the change and then inform the team, or to only inform a subset of the team. This still bypasses the formal approval and review stages. It creates a situation where the change is live and potentially impacting the system before its risks have been fully evaluated by all relevant stakeholders. This undermines transparency and accountability within the development team and the broader IT organization. The professional reasoning process for handling such situations involves prioritizing adherence to established procedures and risk management. Developers should always operate within the defined governance structures. When a potential improvement is identified, the first step is to document the proposed change, outline the expected benefits, and detail the testing strategy. This documentation should then be submitted through the formal change control process for review and approval. If the proposed change is rejected or requires further refinement, the developer must respect that decision and work collaboratively to address the concerns raised. This systematic approach ensures that innovation is balanced with stability and control. Question 4. The assessment process reveals that a PL/SQL developer has identified a potential security vulnerability in a critical database procedure they recently modified. The vulnerability, if exploited, could allow unauthorized access to sensitive customer data. The developer is concerned about the implications of reporting this, as it might reflect poorly on their recent work and potentially delay a project deadline. What is the most professional and ethical course of action for the developer? Option A. Ignore the vulnerability and hope it is not discovered or exploited, as reporting it could cause unnecessary alarm and project delays. Option B. Report the vulnerability directly to the client to ensure they are aware of the potential risk, bypassing internal reporting procedures. Option C. Immediately report the identified vulnerability through the established internal security reporting channel, providing all relevant details for assessment and remediation. Option D. Attempt to fix the vulnerability discreetly, without informing management, or the security team to avoid any negative repercussions on their performance review? The correct answer is C. Immediately report the identified vulnerability through the established internal security reporting channel, providing all relevant details for assessment and remediation. Explanation. Scenario analysis. This scenario presents an ethical dilemma common in software development, where a developer discovers a potential security vulnerability in code they are responsible for. The challenge lies in balancing the immediate need to fix the issue with the potential consequences of disclosure, such as reputational damage or exploitation by malicious actors. The developer must navigate this by adhering to established protocols and prioritizing the integrity and security of the system. Correct approach analysis. The correct approach involves immediately reporting the vulnerability through the established internal channels. This aligns with best professional practices and ethical guidelines for software development. Oracle PL/SQL developers are expected to maintain the security and integrity of the database systems they work with. Prompt internal reporting ensures that the vulnerability can be assessed, prioritized, and remediated by the appropriate security teams without undue delay. This proactive stance minimizes the window of opportunity for exploitation and demonstrates a commitment to responsible disclosure and system security, which is implicitly expected under professional conduct guidelines for IT professionals. Incorrect approaches analysis. Reporting the vulnerability directly to the client without internal consultation is professionally unacceptable. This bypasses internal security protocols and potentially exposes the vulnerability to external parties before a controlled fix can be implemented. It undermines the trust between the development team and their employer and could lead to a breach of contract or confidentiality agreements. Attempting to fix the vulnerability discreetly without informing management or the security team is also professionally unsound. While well-intentioned, this approach carries significant risks. The fix might be incomplete, introduce new issues, or fail to address the root cause. Furthermore, it conceals a known risk from those responsible for overall system security and compliance, which is a failure of transparency and accountability. Ignoring the vulnerability and hoping it goes unnoticed is the most egregious ethical and professional failure. This demonstrates a severe lack of responsibility and disregard for the potential impact on the client's data and operations. It exposes the client to significant security risks, potentially leading to data breaches, financial losses, and severe reputational damage, all of which are direct consequences of neglecting a known vulnerability. Professional reasoning. Professionals facing such situations should follow a structured decision-making process. 1. Identify the issue and its potential impact. 2. Consult internal policies and procedures for handling security vulnerabilities. 3. Report the issue through the designated channels, providing all necessary details. 4. Cooperate fully with the security and development teams to implement a solution. 5. Document all actions taken. This process ensures transparency, accountability, and adherence to professional and ethical standards. Question 5. Investigation of a PL/SQL developer's decision-making process when they discover an undocumented, highly efficient method for data manipulation that could significantly speed up a critical report generation process, but which deviates from established coding standards and has not undergone formal testing. Option A. Inform a junior developer about the undocumented method and let them implement it, as they are eager to learn and can handle the task. Option B. Proceed with the standard documented method for data manipulation, ignoring the undocumented optimization to avoid any potential risks or complications. Option C. Implement the undocumented optimization immediately to meet the report deadline, as the performance gains are substantial and the developer is confident in its correctness. Option D. Thoroughly document the proposed optimization, including its risks and benefits, and submit it for formal code review and testing by the team. Correct answer is D. Thoroughly document the proposed optimization, including its risks and benefits, and submit it for formal code review and testing by the team. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the potential conflict between a developer's desire to optimize performance and the ethical obligation to maintain data integrity and adhere to established coding standards. The developer is aware of a more efficient, albeit undocumented and potentially unstable, method for data manipulation within PL/SQL. The pressure to deliver a feature quickly, coupled with the temptation of a seemingly superior technical solution, creates an ethical dilemma. The core challenge lies in balancing immediate project needs with long-term system stability, maintainability, and adherence to professional coding ethics. Correct approach analysis. The correct approach involves thoroughly documenting the proposed optimization, including its potential risks and benefits, and submitting it through the established code review and testing process. This aligns with professional software development best practices and the implicit ethical guidelines governing software engineering. Oracle's PL/SQL development, like any professional software development, relies on transparency, collaboration, and rigorous testing to ensure code quality and prevent unintended consequences. By seeking peer review and formal testing, the developer upholds the principles of accountability and shared responsibility for code quality. This process ensures that any deviation from standard practice is understood, evaluated, and approved by the team, safeguarding against the introduction of hidden bugs or performance regressions that could impact the application's integrity. Incorrect approach is analysis. Implementing the undocumented optimization without disclosure or testing represents a significant ethical failure. It bypasses established quality assurance procedures, potentially introducing subtle bugs or performance issues that could compromise data integrity or application stability. This approach violates the principle of professional responsibility to deliver reliable and maintainable code. It also undermines team trust and the collaborative development environment. Suggesting the optimization to a junior developer without proper oversight or documentation is also professionally unsound. While seemingly delegating the task, it offloads the responsibility for potential negative consequences without ensuring the junior developer fully understands the risks or the proper procedures for implementing and testing such a change. This can lead to the junior developer making similar ethically questionable decisions in the future and exposes the project to unnecessary risk. Ignoring the optimization and proceeding with the standard, albeit slower, method without considering the potential benefits or discussing it with the team is also not the most professional approach. While it avoids immediate risk, it misses an opportunity for genuine performance improvement if the optimization is indeed valid and can be safely implemented. A truly professional approach involves evaluating all viable options and making informed decisions based on a comprehensive understanding of the trade-offs. Professional reasoning. Professionals should approach such situations by prioritizing transparency, collaboration, and adherence to established processes. When faced with a potential optimization that deviates from standard practice, the decision-making process should involve 1. Identifying the potential benefit and risk. 2. Documenting the proposed change thoroughly, including rationale, implementation details, and potential impacts. 3. Submitting the proposal for peer review and rigorous testing. 4. Making a collective, informed decision based on the review and testing results. This structured approach ensures that decisions are not made in isolation, and that the long-term health and integrity of the system are paramount. Question 6. What factors determine the most effective strategy for optimizing the performance of a complex PL/SQL procedure that processes large volumes of data, ensuring both efficiency and data integrity? Option A. The total number of lines of code in the procedure and the perceived complexity of its logic. Option B. The personal experience of the developer with similar procedures and their intuition about which sections are likely to be slow. Option C. The availability of third-party performance tuning utilities that promise rapid improvements. Option D. The specific SQL statements within the procedure, their execution plans, and the resource consumption identified through profiling tools. The correct answer is D. The specific SQL statements within the procedure, their execution plans, and the resource consumption identified through profiling tools. Explanation. This scenario presents a common challenge in PL/SQL development, optimizing the performance of a critical data processing procedure. The professional challenge lies in balancing the need for speed and efficiency with the imperative to maintain data integrity and adhere to established coding standards, all within the context of the Oracle database program with PL/SQL 1Z0-149. Examinations implied best practices and regulatory framework, which emphasizes correctness, efficiency, and maintainability. The correct approach focuses on understanding the underlying execution plan and identifying bottlenecks through profiling and analysis. This aligns with professional best practices by prioritizing data-driven decisions. By examining the execution plan, developers can pinpoint specific SQL statements or PL/SQL constructs that are consuming excessive resources. Techniques like using explain plan, SQL trace, and DBMS profiler are standard tools for this purpose. This methodical approach ensures that optimizations are targeted and effective, leading to measurable improvements without introducing unintended side effects. Adherence to the principles of efficient coding, as implicitly tested by the 1Z0-149 exam, is paramount. An incorrect approach might involve making broad, speculative changes without proper analysis. For instance, indiscriminately adding hints to SQL statements without understanding their impact on the optimizer's choices can lead to worse performance or incorrect results. This violates the principle of informed decision-making and can be seen as professionally negligent. Another incorrect approach could be to rewrite the entire procedure from scratch based on a perceived but unverified performance issue. This is inefficient, time-consuming, and introduces unnecessary risk of introducing new bugs. Such actions lack the rigor expected in professional development and fail to demonstrate a deep understanding of performance tuning methodologies. The professional decision-making process for similar situations should involve a systematic approach. 1. Define the problem. Clearly identify the performance issue and its impact. 2. Gather data. Use profiling and tracing tools to understand the current execution. 3. Analyze the data. Identify the root cause of the performance bottleneck. 4. Formulate hypotheses. Propose specific testable solutions. 5. Implement and test, apply the proposed solutions and measure their impact. 6. Iterate, refine the solution based on testing results. 7. Document, record the changes made and their outcomes. Question 7. When evaluating the performance of a critical PL/SQL procedure that processes a large volume of transactional data, and initial observations indicate significant execution time, which of the following strategies is the most professionally sound and compliant with Oracle's performance tuning principles? Option A. Immediately propose a hardware upgrade for the database server and network infrastructure, attributing the performance issue to external resource constraints without analyzing the PL/SQL code itself. Option B. Refactor the PL/SQL code to utilize bulk operations, e.g., for all, bulk collect, and optimize SQL statements within the procedure to process data in sets rather than row by row. Option C. Implement aggressive logging of every single row process to capture detailed execution flow, assuming this will indirectly highlight performance issues through log volume. Option D. Manually iterate through each record in the data set using a cursor and perform individual DML operations within the loop, ensuring each operation is committed immediately after processing. The correct answer is B. Refactor the PL/SQL code to utilize bulk operations, e.g., for all, bulk collect, and optimize SQL statements within the procedure to process data in sets rather than row by row. Explanation. This scenario presents a common challenge in PL/SQL development, optimizing the performance of a data-intensive operation without compromising data integrity or violating established coding standards. The professional challenge lies in balancing efficiency gains with the need for robust, maintainable, and compliant code. Developers must consider not only the immediate performance impact, but also the long-term implications for system stability and adherence to Oracle's best practices, which are implicitly governed by the principles of efficient database operation and resource management. The correct approach, which involves profiling the existing PL/SQL code to identify specific bottlenecks, and then implementing targeted optimizations such as bulk operations or efficient SQL constructs, represents best professional practice. This is because it is a systematic, data-driven method that directly addresses the root cause of performance issues. Oracle's own documentation and performance tuning guides emphasize this methodology, promoting the use of built-in features and optimized SQL for maximum efficiency. This aligns with the implicit regulatory expectation of responsible resource utilization within the database environment. An incorrect approach that relies solely on manual row-by-row processing without any attempt at optimization is professionally unacceptable because it ignores well-established performance tuning principles and leads to inefficient resource consumption. This can result in increased processing times, higher system load, and potential timeouts, which are detrimental to the overall health and responsiveness of the database. Ethically, it represents a failure to deliver a solution that meets reasonable performance expectations. Another incorrect approach, such as prematurely introducing complex indexing strategies or hardware upgrades without first analyzing the PL/SQL code, is also professionally flawed. This is a shotgun approach that can be costly, disruptive, and may not even address the actual performance bottleneck, which might be within the PL/SQL logic itself. It demonstrates a lack of analytical rigor and can lead to wasted resources and effort. A professional decision-making process for similar situations should begin with a thorough understanding of the business requirements and performance expectations. This is followed by a systematic analysis of the existing code, using profiling tools to pinpoint performance issues. Once bottlenecks are identified, targeted optimization strategies, prioritizing built-in PL/SQL and SQL features that promote set-based operations, should be implemented and tested. Continuous monitoring and iterative refinement are key to achieving optimal performance while maintaining code quality and adherence to best practices. Question 8. Cost-benefit analysis shows that the current PL/SQL application is experiencing significant performance degradation during peak usage hours, leading to user complaints and potential revenue loss. Several potential optimization strategies have been proposed. Which approach is most aligned with professional best practices for addressing such issues in an Oracle PL/SQL environment? Option A. Immediately implement a comprehensive indexing strategy across all frequently queried tables, assuming that increased indexing will universally improve performance. Option B. Conduct a thorough analysis of SQL execution plans and PL/SQL profiling to pinpoint inefficient code sections, and then implement targeted optimizations, such as rewriting problematic SQL, adding appropriate indexes, or refactoring PL/SQL logic based on identified bottlenecks. Option C. Undertake a complete rewrite of the application's core PL/SQL modules, assuming the existing code is inherently inefficient, without prior detailed performance profiling. Option D. Propose a significant hardware upgrade for the database server, including more RAM and faster storage, to alleviate the performance issues without altering the existing code. The correct answer is B. Conduct a thorough analysis of SQL execution plans and PL/SQL profiling to pinpoint inefficient code sections, and then implement targeted optimizations, such as rewriting problematic SQL, adding appropriate indexes, or refactoring PL/SQL logic based on identified bottlenecks. Explanation. Scenario analysis. This scenario presents a common challenge in database development where performance bottlenecks are identified, impacting user experience and potentially system availability. The challenge lies in selecting the most effective optimization strategy from several plausible options, each with its own trade-offs in terms of implementation effort, risk, and long-term maintainability. The pressure to deliver a quick fix must be balanced against the need for a robust and sustainable solution that adheres to best practices and avoids introducing new issues. Correct approach analysis. The correct approach focuses on understanding the root cause of the performance issue through detailed analysis of execution plans and resource utilization. This aligns with professional best practices in database performance tuning, which emphasize data-driven decision-making. By identifying specific SQL statements or PL/SQL code sections that are inefficient, developers can target their optimization efforts precisely. This minimizes the risk of unintended consequences and ensures that the implemented changes directly address the identified problem. This methodical approach is crucial for maintaining system integrity and adhering to Oracle's recommended development lifecycle, which prioritizes thorough testing and validation before deployment. Incorrect approaches analysis. One incorrect approach involves blindly applying indexing strategies without understanding the query patterns. While indexing can improve performance, over-indexing or indexing inappropriate columns can lead to increased storage overhead, slower DML operations, inserts, updates, deletes, and complex index maintenance. This approach fails to demonstrate due diligence in analyzing the problem and risks introducing new performance degradations or data integrity issues, which could be considered a failure in professional responsibility to deliver a well-engineered solution. Another incorrect approach is to focus solely on hardware upgrades, without investigating software-level optimizations. While hardware can be a factor, it often masks underlying inefficiencies in the database code or schema design. Relying on hardware alone is a costly and often temporary solution that does not address the fundamental performance problems. This approach demonstrates a lack of analytical rigor and a failure to explore more cost-effective and sustainable software-based solutions, potentially violating principles of efficient resource management. A third incorrect approach is to rewrite complex PL/SQL logic without a clear understanding of its original intent or impact. This can introduce bugs, alter business logic, and create new performance issues. Without profiling and testing, such a rewrite is a high-risk endeavor that deviates from a structured, analytical approach to problem-solving. This approach represents a significant professional risk, as it can lead to system instability and data corruption, undermining the trust placed in the developer. Professional reasoning. Professionals should approach performance optimization by first establishing clear performance baselines and then employing a systematic diagnostic process. This involves using Oracle's built-in tools, e.g., SQL Trace, TK-Prof, Explain Plan, AWR reports, to identify the specific areas of concern. Once the root cause is understood, potential solutions should be evaluated based on their expected impact, implementation complexity, and risk. A phased approach, with thorough testing in a non-production environment, is essential before deploying any changes to production. This ensures that optimizations are effective, do not introduce regressions, and are maintainable. Question 9. Operational review demonstrates that a critical PL/SQL procedure is experiencing significant performance degradation, leading to extended processing times for end users. The development team is under pressure to resolve this issue quickly. Which of the following approaches represents the most professional and effective method for addressing this performance bottleneck? Option A. Systematically profile the PL/SQL procedure to identify specific SQL statements or code blocks that are consuming the most resources, analyze their execution plans, and then implement targeted optimizations based on this data. Option B. Add a comprehensive set of new indexes to all tables accessed by the PL/SQL procedure, assuming this will universally improve query performance. Option C. Immediately rewrite the entire PL/SQL procedure using what the team believes to be more modern or efficient coding patterns, without prior performance analysis. Option D. Focus solely on optimizing individual SQL statements within the procedure, disregarding how they are called or processed within the PL/SQL logic. The correct answer is A. Systematically profile the PL/SQL procedure to identify specific SQL statements or code blocks that are consuming the most resources, analyze their execution plans, and then implement targeted optimizations based on this data. Explanation. Scenario analysis. The scenario presents a common challenge in database development, identifying and rectifying performance bottlenecks within PL/SQL code. The professional challenge lies in balancing the need for immediate performance gains with the long-term maintainability, scalability, and adherence to best practices. Rushing into a solution without proper analysis can lead to unintended consequences, such as increased complexity, reduced readability, or even introducing new bugs. The pressure to deliver quickly can tempt developers to choose expedient but suboptimal solutions. Careful judgment is required to select an approach that is not only effective in the short term but also sustainable and robust. Correct approach analysis. The correct approach involves a systematic, data-driven methodology. This begins with accurate performance profiling to pinpoint the exact areas of the PL/SQL code that are consuming the most resources. Tools like SQL Trace, TK-Prof, or the Oracle Enterprise Manager Diagnostic Pack are invaluable here. Once the bottleneck is identified, the next step is to analyze the execution plan of the SQL statements within the PL/SQL code. This analysis helps understand how the database is processing the query and where inefficiencies lie. Based on this understanding, targeted optimizations can be applied. This might involve rewriting SQL statements, adding appropriate indexes, or restructuring the PL/SQL logic to reduce redundant operations or unnecessary context switching between SQL and PL/SQL. This methodical approach ensures that optimizations are applied where they will have the most impact, leading to sustainable performance improvements without compromising code quality or introducing technical debt. This aligns with professional best practices for software development, emphasizing thorough analysis and targeted solutions. Incorrect approach is analysis. One incorrect approach is to immediately rewrite the entire PL/SQL block without first profiling or analyzing the existing code. This is a shotgun approach that wastes development time and risks introducing new problems. It fails to address the root cause of the performance issue and may even degrade performance if the rewritten code is less efficient. Ethically, this represents a failure to use resources responsibly and a disregard for efficient problem solving. Another incorrect approach is to blindly add indexes without understanding the data access patterns or the impact on DML operations. While indexes can improve query performance, poorly chosen or excessive indexes can significantly slow down data modification, insert, update, delete, and consume excessive disk space. This approach lacks analytical rigor and can lead to a net performance degradation. It violates the principle of making informed decisions based on evidence, which is a cornerstone of professional conduct. A third incorrect approach is to focus solely on optimizing SQL statements in isolation, ignoring the PL/SQL context. Performance issues in PL/SQL often stem from the interaction between the procedural code and the SQL it executes. For example, fetching data row by row in a loop and then processing it in PL/SQL can be far less efficient than a single SQL statement that performs the same aggregation or transformation. This approach fails to consider the holistic performance of the application component. It demonstrates a lack of understanding of how PL/SQL and SQL interact to form a complete execution path, leading to incomplete or ineffective optimizations. Professional reasoning: professionals should adopt a structured problem-solving framework. This involves 1. Define the problem clearly: performance degradation. 2. Gather data profiling execution plans. 3. Analyze the data to identify root causes. 4. Develop potential solutions based on the analysis. 5. Evaluate and select the best solution considering impact, effort, and long-term implication. 6. Implement the solution. 7. Test and monitor the results. This iterative process ensures that solutions are effective, efficient, and maintainable, upholding professional standards of quality and accountability. Question 10. The audit findings indicate that a PL/SQL procedure responsible for updating customer order statuses is experiencing significant performance degradation during peak processing hours, leading to delayed order fulfillment. The development team needs to address this issue promptly. Which of the following approaches is the most professional and effective for optimizing this procedure? Option A. Immediately add several new indexes to the tables accessed by the procedure, assuming that indexing is the most common solution for performance problems. Option B. Rewrite the entire procedure from scratch using a different programming paradigm, without first identifying the exact performance bottlenecks. Option C. Implement a series of speculative code changes based on common performance myths and anecdotal evidence from other projects. Option D. Systematically profile the procedure using Oracle's built-in tools to identify specific SQL statements or PL/SQL constructs contributing to the performance bottleneck, and then apply targeted optimizations based on this analysis. Correct answer is D. Systematically profile the procedure using Oracle's built-in tools to identify specific SQL statements or PL/SQL constructs contributing to the performance bottleneck, and then apply targeted optimizations based on this analysis. Explanation: the audit findings indicate a potential performance bottleneck in a critical PL/SQL procedure responsible for processing customer order updates. This scenario is professionally challenging because inefficient code can lead to delayed order fulfillment, increased operational costs, and a negative customer experience. Furthermore, the pressure to resolve performance issues quickly must be balanced against the risk of introducing new bugs or violating data integrity. The chosen approach must align with best practices for PL/SQL optimization and adhere to Oracle's recommended methodologies to ensure maintainability and scalability. The correct approach represents best professional practice because it systematically identifies the root cause of the performance issue through profiling and targeted analysis. This method ensures that optimization efforts are focused on the most impactful areas, preventing wasted development time and the introduction of unnecessary complexity. By using Oracle's built-in tools and adhering to established PL/SQL tuning principles. Developers demonstrate a commitment to robust, efficient, and maintainable code, which is a cornerstone of professional database development. This systematic approach minimizes the risk of unintended side effects and ensures that the solution is sustainable. An incorrect approach that involves blindly adding indexes without proper analysis is professionally unacceptable. This is because adding unnecessary indexes can degrade DML performance, inserts, updates, deletes, and increase storage requirements, potentially creating new performance problems. It also violates the principle of least privilege and efficient resource utilization. Another incorrect approach, such as rewriting the entire procedure without identifying specific performance bottlenecks, is inefficient and risky. It expends significant development effort without a clear understanding of the problem, increasing the likelihood of introducing new errors and failing to address the actual performance issue. A third incorrect approach, relying solely on anecdotal evidence or guesswork to implement optimizations, lacks a data-driven foundation. This can lead to ineffective solutions, wasted resources, and a failure to meet performance targets, undermining professional credibility and potentially causing further system instability. Professionals should employ a structured decision-making process when addressing performance issues. This involves 1. Understanding the business impact of the performance problem, 2. Gathering data through profiling and monitoring tools, 3. Forming hypotheses about the root cause, 4. Testing these hypotheses with targeted changes, 5. Measuring the impact of changes, and 6. Documenting the solution and its rationale. This iterative, data-driven approach ensures that optimizations are effective, efficient, and maintainable. Question 11. Market research demonstrates that a critical customer-facing PL/SQL procedure, responsible for processing high volumes of daily transactions, has experienced a significant increase in execution time over the past quarter, impacting user satisfaction. The development team needs to address this performance degradation. Which of the following diagnostic and optimization strategies is the most appropriate first step to ensure efficient and effective resolution? Option A. Analyze the execution plan of the SQL statements within the PL/SQL procedure to identify inefficient operations and data access paths. Option B. Rewrite the entire PL/SQL procedure using a different programming paradigm, without prior analysis of the existing code's performance characteristics. Option C. Proactively add indexes to all tables accessed by the PL/SQL procedure, assuming they are the cause of the slowdown. Option D. Recommend an immediate upgrade of the database server hardware to provide more processing power and memory. The correct answer is A. Analyze the execution plan of the SQL statements within the PL/SQL procedure to identify inefficient operations and data access paths. Explanation. Scenario analysis. This scenario presents a common challenge in database development where performance bottlenecks can directly impact user experience and business operations. Professional challenge lies in identifying the root cause of performance degradation and implementing an effective solution without introducing new issues or violating established coding standards and best practices. The need for a deep understanding of PL/SQL execution plans and optimization techniques is paramount. Correct approach analysis. The correct approach involves analyzing the execution plan of the problematic PL/SQL code. This is best professional practice because it directly addresses the performance issue by identifying inefficient SQL statements or PL/SQL constructs. Oracle's Optimizer generates execution plans to show how SQL statements are processed. By examining this plan, developers can pinpoint areas like full table scans on large tables, inefficient join methods, or unnecessary data retrieval, which are common causes of performance degradation. This systematic, data-driven approach aligns with the principles of efficient software development and resource management, ensuring that optimizations are targeted and effective. It avoids guesswork and focuses on verifiable performance metrics. Incorrect approach is analysis. One incorrect approach is to blindly add indexes without understanding the query's access patterns. This can lead to performance degradation rather than improvement. Indexes incur overhead for DML operations, insert, update, delete, and can sometimes be ignored by the optimizer if they are not selective or if the query is not written to utilize them effectively. This approach fails to adhere to the principle of targeted optimization and can violate the implicit ethical obligation to deliver efficient and maintainable code. Another incorrect approach is to rewrite the PL/SQL code extensively without first identifying the specific performance bottleneck. This shotgun approach is inefficient and risky. It can introduce new bugs, obscure the original problem, and waste development time. It demonstrates a lack of analytical rigor and a failure to follow a structured problem-solving methodology, which is a cornerstone of professional software engineering. A further incorrect approach is to simply increase hardware resources, e.g., more memory, faster disks, without optimizing the code. While hardware can sometimes alleviate performance issues, it is often a costly and temporary fix. It does not address the underlying inefficiency in the code itself, and can be seen as a failure to exercise due diligence in optimizing the application's logic, potentially leading to unnecessary expenditure and a failure to meet performance targets sustainably. Professional reasoning. Professionals should approach performance issues by first establishing a baseline of current performance. Then they should use diagnostic tools such as Explain Plan and SQL Trace to understand how the code is executing. The focus should be on identifying the most significant bottlenecks. Once identified, targeted optimizations should be implemented and tested rigorously to confirm improvement. This iterative process, guided by data and analysis, ensures that solutions are effective, efficient, and maintainable, upholding professional standards of quality and responsibility. Question 12. Benchmark analysis indicates that a critical PL/SQL procedure is experiencing significant performance degradation, leading to increased transaction times. The procedure processes large volumes of data and is invoked frequently. What is the most effective and professional approach to diagnose and resolve this performance issue? Option A. Apply various SQL hints to the statements within the procedure in an attempt to force a different execution path without prior analysis. Option B. Analyze the execution plans of the SQL statements within the PL/SQL procedure. Profile the PL/SQL code to identify time-consuming sections and implement targeted optimizations based on these findings. Option C. Immediately rewrite the entire PL/SQL procedure using a different coding style, assuming the current structure is inherently inefficient. Option D. Recommend an immediate upgrade of the database server hardware and memory, as the current infrastructure is likely the bottleneck. The correct answer is B. Analyze the execution plans of the SQL statements within the PL/SQL procedure. Profile the PL/SQL code to identify time-consuming sections, and implement targeted optimizations based on these findings. Explanation. Scenario analysis. This scenario presents a common challenge in database development where performance bottlenecks are identified. Professional difficulty lies in accurately diagnosing the root cause of performance degradation and implementing effective solutions without introducing new issues or violating best practices. The pressure to resolve performance problems quickly can lead to hasty decisions, making a systematic and informed approach crucial. Adhering to the Oracle PL/SQL development guidelines and best practices is paramount to ensure maintainability, scalability, and data integrity. Correct approach analysis. The correct approach involves a methodical investigation of the PL/SQL code and its execution plan. This includes analyzing the SQL statements within the PL/SQL blocks for inefficiencies, such as missing indexes, suboptimal join conditions, or unnecessary full table scans. Profiling the PL/SQL code to identify specific sections consuming the most time is also a key step. Understanding the execution plan generated by the Oracle Optimizer is critical for pinpointing where the database is spending its resources. Implementing targeted optimizations, such as rewriting SQL, adding appropriate indexes, or restructuring PL/SQL logic based on this analysis, represents best professional practice. This aligns with the principles of efficient database programming and adheres to the implicit regulatory expectation of delivering performant and reliable database solutions, as outlined in Oracle's documentation and common industry standards for PL/SQL development. Incorrect approaches analysis. One incorrect approach is to indiscriminately add hints to SQL statements without a thorough understanding of their impact. Hints can override the optimizer's decisions, and if misused, can lead to worse performance or incorrect results. This is professionally unacceptable as it bypasses systematic analysis and relies on guesswork, potentially violating the principle of delivering robust and predictable code. Another incorrect approach is to focus solely on hardware upgrades without addressing potential software or code inefficiencies. While hardware can impact performance, it's often a costly and less effective solution if the underlying code is poorly written. This approach fails to address the root cause and can be seen as a dereliction of duty to optimize the application logic itself, which is a core responsibility of a PL/SQL developer. A third incorrect approach is to rewrite the entire PL/SQL block without identifying specific performance issues. This is inefficient, time-consuming, and carries a high risk of introducing new bugs or performance regressions. It demonstrates a lack of analytical rigor and a failure to apply targeted problem-solving techniques. Professional reasoning. Professionals should approach performance issues by first establishing a baseline, then systematically identifying bottlenecks through profiling and execution plan analysis. Solutions should be data-driven and targeted. Before implementing any changes, thorough testing in a non-production environment is essential. Documentation of the problem. The analysis and the implemented solution is also a critical part of professional practice. This ensures transparency, facilitates future troubleshooting, and supports knowledge transfer within the team. Question 13. Process analysis reveals that a critical business requirement is to generate customer activity reports that summarize transaction details. However, these reports must not expose sensitive customer personally identifiable information, PI, such as full names, addresses, or credit card numbers to the analysts who will be consuming them. The PL/SQL procedures responsible for data aggregation and report generation are currently designed to retrieve all necessary transaction data, including the sensitive PII, before performing the summarization. Which of the following approaches best adheres to data privacy regulations and professional best practices for handling sensitive data within the Oracle database? Option A. Rely solely on network-level security and database user privileges to protect sensitive customer PII without modifying the PL/SQL procedures. Option B. Directly query and display all sensitive customer PII in the generated reports, assuming that only authorized analysts will have access to the report output. Option C. Implement data masking techniques within the PL/SQL procedures to obfuscate sensitive customer PII before it is aggregated and presented in the report. Option D. Store all sensitive customer PII in plain text within the database, with the assumption that the database itself is secure from external threats. Correct answer is C. Implement data masking techniques within the PL/SQL procedures to obfuscate sensitive customer PII before it is aggregated and presented in the report. Explanation. Scenario analysis. This scenario presents a professional challenge related to data integrity and security within an Oracle database environment, specifically concerning the handling of sensitive customer information. The core difficulty lies in balancing the need for efficient data processing and reporting with the absolute requirement to protect personally identifiable information, PI, as mandated by data privacy regulations. Developers must make critical decisions about data access and manipulation that have direct implications for compliance and customer trust. The pressure to deliver functional code quickly can sometimes lead to overlooking security best practices, making careful judgment and adherence to established guidelines paramount. Correct approach analysis. The correct approach involves implementing robust data masking techniques within PL/SQL procedures. This aligns with the principle of least privilege and data minimization, fundamental tenets of data privacy regulations. By masking sensitive data before it is exposed in reports or intermediate tables, the risk of unauthorized access or accidental disclosure is significantly reduced. This method ensures that while data can be processed and analyzed, the actual sensitive details remain protected, thereby upholding regulatory compliance and maintaining customer confidentiality. This proactive security measure is a cornerstone of responsible database development. Incorrect approaches analysis. One incorrect approach involves directly querying and displaying sensitive customer data in reports without any form of obfuscation or masking. This directly violates data privacy regulations by exposing PII unnecessarily, increasing the risk of data breaches, and leading to severe legal and financial penalties. It demonstrates a failure to implement basic security controls and a disregard for the ethical obligation to protect customer information. Another incorrect approach is to rely solely on external security measures, such as network firewalls or access control lists, to protect sensitive data within the database. While these are important layers of defense, they do not address the risk of data exposure from within the application logic itself. If a PL/SQL procedure is designed to retrieve and process sensitive data without internal safeguards, these external measures become insufficient. This approach fails to implement defense in depth for data protection. A third incorrect approach is to store sensitive customer data in plain text within the database, assuming that only authorized personnel will have access. This is a critical security vulnerability. Regulations often mandate encryption or pseudonymization for sensitive data, even when access is restricted. Storing data in plain text makes it susceptible to compromise if database credentials are leaked or if internal threats exist. It represents a failure to implement appropriate data protection measures at the storage level. Professional reasoning. Professionals should adopt a risk-based approach to data handling. This involves identifying sensitive data, understanding the regulatory requirements for its protection, and implementing technical controls to mitigate risks. When developing PL/SQL code that interacts with sensitive data, developers should always consider the potential for data exposure and incorporate security measures such as data masking, encryption, or pseudonymization directly into the code. Regular security audits and adherence to secure coding practices are essential. In situations involving sensitive data, prioritizing compliance and security over immediate development speed is a hallmark of professional integrity and responsible practice. Question 14. Risk assessment procedures indicate a critical data inconsistency has been discovered in the production database, affecting key financial reports. Stakeholders are demanding an immediate resolution to prevent further business impact, suggesting a quick and dirty manual data correction or a simple script to fix only the affected records. As a PL/SQL developer, what is the most professionally responsible approach to address this data inconsistency? Option A. Document the data inconsistency as a known issue and await further instructions or a scheduled maintenance window for a potential fix. Option B. Manually update the inconsistent records directly in the production database to immediately resolve the reported issues. Option C. Create a one-time script to fix only the currently identified inconsistent records, without implementing any error handling or preventative measures. Option D. Develop a robust PL/SQL stored procedure that identifies the root cause of the inconsistency, corrects the affected data, and includes logic to prevent future occurrences, followed by thorough testing and a controlled deployment. The correct answer is D. Develop a robust PL/SQL stored procedure that identifies the root cause of the inconsistency, corrects the affected data, and includes logic to prevent future occurrences, followed by thorough testing and a controlled deployment. Explanation. Scenario analysis. This scenario presents a professional challenge because it requires a PL/SQL developer to balance the immediate need for data integrity and performance with the long-term implications of code maintainability and adherence to best practices. The pressure to deliver a quick fix for a critical bug can lead to shortcuts that compromise code quality and introduce future risks. The stakeholders' directive for a quick and dirty solution, while understandable from a business perspective, directly conflicts with the developer's responsibility to produce robust and sustainable code. This tension necessitates careful judgment to find a solution that addresses the immediate problem without creating larger issues down the line, all while managing stakeholder expectations. Correct approach analysis. The correct approach involves identifying the root cause of the data inconsistency and implementing a PL/SQL solution that corrects the data and prevents recurrence. This might involve creating a stored procedure or function that performs the necessary data validation and correction logic. This approach represents best professional practice because it prioritizes data integrity, which is a fundamental requirement for any database application. By addressing the root cause, the solution is more robust and less likely to lead to future issues. Furthermore, well-structured PL/SQL code, even for a fix, promotes maintainability and understandability, aligning with the principles of good software engineering. This proactive stance minimizes technical debt and ensures the long-term health of the application, which is ethically and professionally responsible. Incorrect approaches analysis. Manually updating the data directly in the production environment without a programmatic solution is a significant regulatory and ethical failure. This approach bypasses all audit trails and version control, making it impossible to track who made the changes, when, and why. It violates principles of data governance and introduces a high risk of accidental data corruption or further inconsistencies. It also fails to address the underlying bug, meaning the problem will likely recur. Implementing a quick, ad hoc script that only fixes the current inconsistent records without any error handling or validation mechanism is also professionally unacceptable. While it might appear to solve the immediate problem, it lacks the robustness required for production systems. Such a script would not prevent future inconsistencies if the same conditions arise, and it could potentially introduce new errors if not carefully tested. This demonstrates a lack of due diligence and a failure to consider the long-term impact on system stability. Ignoring the bug and documenting it as a known issue without proposing a fix is a failure to uphold professional responsibility. While documentation is important, it does not absolve the developer of the duty to address critical data integrity problems. This approach prioritizes expediency over correctness and can lead to a gradual erosion of trust in the data and the application. Professional reasoning. Professionals should approach such situations by first thoroughly understanding the problem and its impact. This involves investigating the root cause rather than just treating the symptoms. Next, they should evaluate potential solutions, considering not only immediate effectiveness, but also long-term maintainability, scalability, and adherence to best practices. Communication with stakeholders is crucial. Explaining the risks associated with quick fixes and advocating for a more robust solution, even if it takes slightly longer, is a key aspect of professional integrity. A structured approach involving design, development, testing, and deployment should be followed for any code change, especially in a production environment. Question 15. The performance metrics show a noticeable degradation in the response time of the order processing system, specifically impacting the PL/SQL procedures responsible for updating inventory levels and generating invoices. The development team suspects that the recent increase in transaction volume is overwhelming the existing code. Which of the following diagnostic and resolution strategies would be the most effective and professionally sound approach to address this performance issue? Option A. Apply a series of performance tuning hints to the SQL statements within the PL/SQL code, hoping to find a combination that improves execution speed. Option B. Rewrite the entire PL/SQL code from scratch using a different programming paradigm, without first identifying the specific performance bottlenecks. Option C. Immediately add more memory to the database server, assuming that insufficient resources are the primary cause of the performance degradation. Option D. Analyze the execution plans of the SQL statements within the problematic PL/SQL procedures. Identify inefficient queries or missing indexes, and refactor the SQL or add appropriate indexes based on the analysis. The correct answer is D. Analyze the execution plans of the SQL statements within the problematic PL/SQL procedures. Identify inefficient queries or missing indexes, and refactor the SQL or add appropriate indexes based on the analysis. Explanation. The performance metrics show a significant increase in query execution times for critical customer-facing applications. This scenario is professionally challenging because it directly impacts user experience, potentially leading to customer dissatisfaction, lost revenue, and reputational damage. The PL/SQL developer must diagnose the root cause and implement a solution efficiently and effectively, adhering to best practices and Oracle's recommended guidelines for performance tuning. The correct approach involves a systematic and data-driven investigation of the PL/SQL code and its execution plan. This includes analyzing the SQL statements within the PL/SQL blocks, identifying inefficient joins, missing indexes, or suboptimal query logic. Utilizing Oracle's built-in performance tuning tools, such as Explain Plan, SQL Trace, and AWR reports, is crucial for pinpointing bottlenecks. Refactoring the PL/SQL code to use more efficient constructs, optimizing SQL queries, and ensuring appropriate indexing strategies are implemented represent best professional practice. This aligns with Oracle's documentation and recommendations for performance tuning, emphasizing a methodical approach to identify and resolve performance issues without introducing new problems. An incorrect approach would be to make speculative changes to the PL/SQL code or database schema without proper analysis. For instance, randomly adding hints to SQL statements without understanding their impact can lead to worse performance or unintended consequences. Similarly, blindly creating new indexes without analyzing the query patterns can increase storage overhead and slow down DML operations, violating the principle of efficient database design and maintenance. Another incorrect approach is to focus solely on the PL/SQL code itself, ignoring the underlying SQL statements and their execution plans, as the performance bottleneck often lies within the SQL execution rather than the procedural logic. This demonstrates a lack of understanding of how PL/SQL interacts with the Oracle database engine and fails to address the true source of the performance degradation. Professionals should adopt a structured decision-making process for performance tuning. This involves 1. Defining the problem clearly and quantifying its impact. 2. Gathering relevant performance data using appropriate tools. 3. Analyzing the data to identify the root cause. 4. Developing and testing potential solutions in a controlled environment. 5. Implementing the chosen solution and monitoring its effectiveness. 6. Documenting the changes and their outcomes. This systematic approach ensures that solutions are targeted, effective, and do not introduce new issues, adhering to professional standards of quality and reliability. Question 16. The performance metrics show a significant increase in query execution times for critical customer-facing reports, impacting user experience. As a PL/SQL developer, you are tasked with identifying and resolving the performance bottleneck. Which of the following approaches is the most professional and effective for diagnosing and resolving this issue? Option A. Increase the PGA and SGA memory parameters of the database instance to provide more resources for query processing. Option B. Rewrite the entire PL/SQL code for the reports from scratch without initial analysis, assuming the existing code is inherently inefficient. Option C. Analyze the execution plans of the SQL statements within the affected PL/SQL blocks to identify inefficient operations and refactor the SQL or PL/SQL code accordingly. Option D. Add numerous SQL hints to the queries within the PL/SQL code to force specific execution paths, hoping to improve performance. The correct answer is C. Analyze the execution plans of the SQL statements within the affected PL/SQL blocks to identify inefficient operations and refactor the SQL or PL/SQL code accordingly. Explanation. The performance metrics show a significant increase in query execution times for critical customer-facing reports. This scenario is professionally challenging because it directly impacts user experience and potentially business operations, requiring a developer to balance performance optimization with code integrity and adherence to established development standards. The pressure to quickly resolve performance issues can lead to rushed solutions that might introduce new problems or violate best practices. The correct approach, which involves analyzing execution plans and identifying inefficient SQL statements within PL/SQL blocks, represents best professional practice because it directly addresses the root cause of the performance degradation. This method aligns with Oracle's recommended performance tuning methodologies, emphasizing a systematic and data-driven approach. By examining the execution plan, a developer can understand how the database is processing the SQL, identify bottlenecks such as full table scans on large tables, missing indexes, or suboptimal join orders, and then refactor the PL/SQL code or SQL statements accordingly. This adheres to the principle of writing efficient and maintainable code, a core tenet of Oracle PL/SQL development. An incorrect approach that involves indiscriminately adding hints to SQL statements without understanding the execution plan is professionally unacceptable. This is because hints can override the optimizer's decisions, potentially leading to worse performance in different data distributions or database versions. It bypasses the fundamental understanding of query execution and can make the code harder to maintain and debug. This approach fails to adhere to the principle of writing understandable and robust code. Another incorrect approach, such as increasing the PGA program global area or SGA system global area memory parameters without a clear understanding of the impact on overall system performance and other applications, is also professionally unacceptable. This is a system-level tuning activity that should be performed by DBAs and requires a comprehensive understanding of the entire database environment. Incorrectly adjusting these parameters can lead to resource contention, instability, and performance degradation across the entire database, violating the principle of responsible system resource management. A third incorrect approach, which is to simply rewrite the PL/SQL code from scratch without profiling or analyzing the existing code, is professionally unsound. This is a wasteful and risky endeavor. It ignores the potential for targeted optimizations within the existing logic and introduces a high probability of introducing new bugs or performance regressions. This violates the principle of iterative improvement and efficient problem solving. The professional reasoning process for such situations should involve 1. Understanding the reported problem and its impact. 2. Gathering relevant data, including performance metrics and execution plans. 3. Systematically analyzing the data to identify the root cause. 4. Developing targeted solutions based on the analysis. 5. Testing the solutions thoroughly in a development or test environment. 6. Implementing the validated solutions and monitoring their impact. 7. Documenting the changes and the reasoning behind them. This structured approach ensures that solutions are effective, efficient, and do not introduce unintended consequences, aligning with professional standards for database development. Question 17. The efficiency study reveals that a critical customer reporting module is experiencing significant performance degradation, leading to user complaints about slow response times. The development team needs to address this issue promptly. Which of the following approaches represents the most professional and effective strategy for resolving the performance bottleneck? Option A. Randomly modify PL/SQL procedures and functions within the reporting module, hoping to stumble upon a fix that improves performance. Option B. Analyze the execution plans of the SQL statements within the reporting module and review the PL/SQL code for inefficient constructs. Then implement targeted optimizations such as adding appropriate indexes or rewriting problematic SQL queries. Option C. Immediately allocate additional server resources, such as increasing the database server's memory or upgrading to faster storage, to alleviate the perceived strain on the system. Option D. Implement a complex caching layer at the application level to serve report data, bypassing direct database queries for frequently accessed information, without first investigating the underlying database performance. The correct answer is B. Analyze the execution plans of the SQL statements within the reporting module and review the PL/SQL code for inefficient constructs. Then implement targeted optimizations such as adding appropriate indexes or rewriting problematic SQL queries. Explanation. Scenario analysis. The scenario presents a common challenge in database development where performance bottlenecks are identified. The professional's task is to diagnose and resolve these issues efficiently and effectively. The challenge lies in balancing the need for rapid resolution with the imperative to maintain data integrity, adhere to coding standards, and ensure long-term maintainability, all within the context of Oracle PL/SQL development, best practices, and potential regulatory compliance. Though no specific external regulations are mentioned, internal Oracle guidelines and best practices act as the governing framework. Correct approach analysis. The correct approach focuses on a systematic, data-driven investigation using Oracle's built-in performance tuning tools and methodologies. This aligns with the Oracle Database Program with PL/SQL curriculum's emphasis on understanding execution plans, indexing strategies, and efficient PL/SQL coding. By analyzing execution plans and identifying inefficient SQL statements or PL/SQL constructs, developers can pinpoint the root cause of performance degradation. Implementing appropriate indexing, rewriting SQL for better performance, or optimizing PL/SQL logic directly addresses the identified bottlenecks. This method is best professional practice because it is methodical, verifiable, and directly targets the performance issue without introducing unnecessary complexity or risk. It adheres to the principle of least change and maximum impact, ensuring that solutions are robust and maintainable. Correct approach is analysis, an approach that immediately resorts to increasing hardware resources, e.g., more memory, faster disks, without a thorough performance analysis is professionally unacceptable. This is a brute force solution that masks underlying inefficiencies rather than resolving them. It is costly, may not solve the problem if the bottleneck is in the code or database design, and violates the principle of efficient resource utilization. Ethically, it represents a failure to perform due diligence and a potential waste of organizational resources. Another incorrect approach would be to randomly alter PL/SQL code or database structures without understanding the impact. This can lead to unintended consequences, such as introducing new performance issues, corrupting data, or violating application logic. It demonstrates a lack of analytical rigor and a disregard for the potential negative impacts on the system and its users. This approach is ethically questionable, as it risks system stability and data integrity without a clear, justified reason. A third incorrect approach might involve implementing complex caching mechanisms or middleware solutions without first exhausting simpler, more direct optimizations within the database and PL/SQL code. While these can be valid performance enhancement techniques, they add layers of complexity and potential points of failure. They are often a last resort when fundamental database and code optimizations have been fully explored and found insufficient. Implementing them prematurely is inefficient and can obscure the true performance bottlenecks. Professional reasoning. Professionals should approach performance issues with a structured methodology. First, clearly define the problem and its scope. Second, gather data using diagnostic tools, e.g., SQL trace, explain plan, AWR reports. Third, analyze the data to identify the root cause. Fourth, develop and test potential solutions, prioritizing those that are least intrusive and most likely to resolve the issue. Fifth, implement the chosen solution and monitor its effectiveness. This systematic process ensures that solutions are well-founded, minimize risk, and adhere to best practices for database development and maintenance. Question 18. Strategic planning requires a thorough understanding of the impact of PL/SQL code on database performance. A critical business report is experiencing significant delays due to a poorly optimized PL/SQL procedure that processes a large volume of data. The development team is under pressure to resolve this issue quickly. Which of the following approaches best balances immediate resolution with long-term system health and maintainability? Option A. Analyze the PL/SQL procedure to identify inefficient SQL statements and data processing logic. Then refactor the code to incorporate optimal indexing, efficient query constructs, and minimize redundant operations. Option B. Advise stakeholders that the current performance is acceptable given the complexity of the data and suggest users adjust their expectations for report generation times. Option C. Implement a temporary table within the PL/SQL procedure to cache intermediate results, even if the underlying query remains inefficient, to speed up the final report generation. Option D. Increase the server's hardware resources, such as CPU and memory, to compensate for the slow execution of the PL/SQL procedure without modifying the code itself. The correct answer is A. Analyze the PL/SQL procedure to identify inefficient SQL statements and data processing logic, then refactor the code to incorporate optimal indexing, efficient query constructs, and minimize redundant operations. Explanation. Scenario analysis. This scenario presents a common challenge in database development where performance optimization directly impacts user experience and system stability. The professional challenge lies in balancing the immediate need for a functional solution with the long-term implications of code quality and maintainability. A rushed implementation, even if it addresses the immediate bug, can introduce technical debt, increase the risk of future errors, and make it harder for other developers to understand and modify the code. The pressure to deliver quickly, often from stakeholders, necessitates careful judgment to avoid compromising established development standards and best practices. Correct approach analysis. The correct approach involves thoroughly understanding the root cause of the performance issue and then implementing a solution that adheres to PL/SQL best practices, including proper indexing, efficient query writing, and avoiding unnecessary operations within loops. This approach represents best professional practice because it prioritizes code quality, maintainability, and long-term system health. From a regulatory and ethical standpoint, it aligns with the implicit expectation of delivering reliable and robust software. While the 1Z0-149 exam doesn't prescribe specific external regulations for PL/SQL development, The principles of professional conduct in software engineering dictate a commitment to quality and due diligence. This approach ensures that the fix is not just a patch, but a well-engineered solution that minimizes future risks and supports the overall integrity of the database application. Incorrect approaches analysis. One incorrect approach involves implementing a quick fix by adding a temporary table or a complex hard-coded workaround without addressing the underlying query inefficiency. This is professionally unacceptable because it introduces significant technical debt. The temporary table might become stale, leading to incorrect data, and the hard-coded workaround is brittle and difficult to maintain, violating principles of good software design. It also fails to address the core problem, leaving the system vulnerable to similar performance issues in the future. Another incorrect approach is to simply increase hardware resources, e.g., more memory, faster CPU, without investigating the code. While this might temporarily mask the performance problem, it is an inefficient and costly solution. It fails to address the root cause within the PL/SQL code, which is the responsibility of the developer. Ethically, it represents a failure to apply due diligence and a disregard for efficient resource utilization. It also bypasses the opportunity to improve the application's design and performance through code optimization. A third incorrect approach is to ignore the performance issue, assuming it's a minor inconvenience that users will tolerate. This is professionally irresponsible and ethically questionable. It demonstrates a lack of commitment to delivering a high-quality product and can lead to significant user dissatisfaction, decreased productivity, and potential business impact. It also fails to uphold the professional standard of ensuring the application functions as intended and performs optimally. Professional reasoning. Professionals should approach such situations by first prioritizing a thorough root cause analysis. This involves using diagnostic tools and techniques to understand precisely why the performance degradation is occurring. Once the cause is identified, the next step is to design and implement a solution that is not only effective, but also adheres to established PL/SQL coding standards and best practices for performance optimization. This includes considering factors like data volume, query complexity, and indexing strategies. Before deploying any fix, it should be rigorously tested in a development or staging environment to ensure it resolves the issue without introducing new problems. Communication with stakeholders about the identified issue, the proposed solution, and the expected timeline is crucial. This systematic approach ensures that solutions are robust, maintainable, and contribute to the long-term health of the application, aligning with professional integrity and the implicit requirements of delivering quality software. Question 19. The evaluation methodology shows a senior PL/SQL developer is tasked with implementing a critical data validation routine for a financial transaction processing system. The project manager, under pressure to meet a tight go-live date, requests that the developer temporarily disable a specific set of validation checks within the PL/SQL code to expedite deployment, promising to re-enable them in a subsequent patch. What is the most professionally responsible course of action for the developer? Option A. Implement the requested change to disable the validation checks, documenting the action in the code comments, and proceeding with the deployment to meet the deadline. Option B. Implement the change to disable the validation checks and then, without informing management, immediately work on a separate patch to re-enable them before the system goes live. Option C. Refuse to implement the change outright, citing the importance of data integrity and refusing to compromise on the current code's robustness. Option D. Document the risks associated with disabling the validation checks, seek explicit written approval from management for the temporary bypass, and propose alternative risk mitigation strategies or a phased implementation plan. The correct answer is A. Implement the requested change to disable the validation checks, documenting the action in the code comments, and proceeding with the deployment to meet the deadline. Explanation. The evaluation methodology shows a scenario where a senior developer, responsible for developing PL/SQL code for a financial reporting application, is asked to bypass standard validation checks to meet an aggressive deadline. This presents a significant professional challenge due to the inherent conflict between project timelines and the critical need for data integrity and security in financial systems. The developer must balance stakeholder pressure with their professional responsibility to deliver robust and compliant code. The correct approach, which involves documenting the risks associated with bypassing validation, seeking explicit written approval from management, and proposing alternative risk mitigation strategies represents best professional practice. This aligns with Oracle's recommended development lifecycle and general software engineering ethics, which emphasize thorough testing, risk management, and clear communication. Specifically, in the context of Oracle Database Program with PL/SQL, robust validation is fundamental to maintaining data integrity, preventing unauthorized access, and ensuring the accuracy of financial reports, which are often subject to regulatory scrutiny. Documenting the decision and its rationale provides an audit trail and protects both the developer and the organization. Seeking written approval ensures accountability and shared responsibility for the decision. Proposing alternatives demonstrates a proactive and responsible approach to problem solving. An incorrect approach would be to proceed with bypassing the validation checks without proper documentation or approval. This failure constitutes a significant regulatory and ethical lapse. It directly violates principles of data integrity and security, which are paramount in financial applications. Such an action could lead to inaccurate financial reporting, potential financial losses, and severe legal and regulatory penalties for the organization. Ethically, it breaches the developer's duty to act with due care and diligence. Another incorrect approach would be to refuse to implement the change without offering any constructive alternatives or engaging in further discussion with management. While maintaining ethical standards is crucial, a complete refusal without attempting to find a compromise or educate stakeholders on the risks can be seen as uncooperative and detrimental to team dynamics and project progress. This approach fails to demonstrate professional problem-solving skills and can create unnecessary friction. A third incorrect approach would be to implement the change and then attempt to fix it later without informing management of the initial bypass. This is a severe ethical failure involving deception and a lack of transparency. It compounds the initial risk by introducing uncertainty about the system's state and potentially hiding critical vulnerabilities. This approach undermines trust and creates a significant compliance risk. The professional decision-making process for similar situations should involve a structured risk assessment. First, the developer must clearly understand the business requirement and the technical implications of the proposed change. Second, they should identify and quantify the risks associated with the change, particularly concerning data integrity, security, and compliance. Third, they should communicate these risks clearly and concisely to management, providing evidence and potential consequences. Fourth, they should propose alternative solutions that mitigate risks while still aiming to meet business objectives, even if they require more time or resources. Finally, any decision to proceed with a risky change must be formally documented and approved in writing by appropriate management, ensuring accountability and a clear understanding of the trade-offs. Question 20. System analysis indicates that a PL/SQL procedure is being developed to process customer financial transactions. This procedure requires access to customer account numbers, transaction amounts, and customer names. The development team is debating the most secure method to handle this sensitive data within the procedure to prevent unauthorized disclosure. Which of the following approaches best adheres to security best practices and regulatory compliance for handling sensitive data within PL/SQL? Option A. Store sensitive customer data directly as hard-coded literals within the PL/SQL procedure source code. Option B. Rely solely on the application layer to enforce access controls for the data that the PL/SQL procedure will retrieve. Option C. Grant the PL/SQL procedure direct select, insert, update, and delete privileges on all tables containing customer financial data. Option D. Implement row-level security policies and use encrypted data types for sensitive columns accessed by the procedure, ensuring the procedure only has select privileges on necessary columns. The correct answer is D. Implement row-level security policies and use encrypted data types for sensitive columns accessed by the procedure, ensuring the procedure only has select privileges on necessary columns. Explanation. Scenario analysis. This scenario presents a common challenge in PL/SQL development, managing sensitive data within stored procedures. The professional challenge lies in balancing the need for data access with the imperative to protect confidential information from unauthorized exposure. Developers must make informed decisions about how to handle data that, if mishandled, could lead to significant security breaches and regulatory noncompliance. The complexity arises from the fact that PL/SQL procedures often operate with elevated privileges, making them potential vectors for data exfiltration if not secured properly. Correct approach analysis. The correct approach involves implementing robust security measures directly within the PL/SQL code or through database-level security configurations that the PL/SQL code leverages. This aligns with the principle of least privilege and defense in depth. By restricting access to sensitive data to only what is absolutely necessary for the procedure's function, and by encrypting or masking this data when it's not actively being processed, developers adhere to best practices for data security. This proactive approach minimizes the attack surface and reduces the risk of accidental or malicious data exposure, which is paramount in maintaining data integrity and compliance with Oracle's security guidelines and general data protection principles. Incorrect approaches analysis. One incorrect approach is to grant the PL/SQL procedure broad, unrestricted access to all tables containing sensitive information. This violates the principle of least privilege. If the procedure is compromised or contains a vulnerability, an attacker could gain access to all sensitive data, leading to a severe data breach. This is a direct contravention of security best practices and could result in regulatory penalties if sensitive data is exposed. Another incorrect approach is to store sensitive data in plain text within the PL/SQL code itself, perhaps as hard-coded literals or within global variables that are not properly secured. This is highly insecure. If the source code is ever exposed, the sensitive data is immediately compromised. This practice is fundamentally flawed from a security perspective and would be considered negligent. A third incorrect approach is to rely solely on external application-level security to protect the data accessed by the PL/SQL procedure, without implementing any specific security controls within the database or the procedure itself. While application-level security is important, it does not absolve the database developer from securing the data at the source. PL/SQL procedures often run with database privileges, and if these privileges are not carefully managed, the data can be exposed regardless of application security. This creates a gap in the security posture. Professional reasoning. Professionals should adopt a risk-based decision-making framework. This involves identifying sensitive data, understanding the potential impact of its compromise, and then implementing layered security controls. For PL/SQL development, this means 1. Data classification. Clearly identify what data is sensitive. 2. Least privilege. Grant only the minimum necessary privileges to the PL/SQL procedure and the user executing it. 3. Secure coding practices. Avoid hard-coding sensitive information. Use secure methods for data retrieval and manipulation. 4. Encryption and masking. Employ encryption for data at rest and in transit where appropriate. Use data masking techniques for non-production environments or for data that doesn't require full visibility. 5. Auditing and monitoring. Implement robust auditing to track access to sensitive data and monitor for suspicious activity. 6. Regular security reviews. Periodically review the security of PL/SQL code and database configurations.